error analysis. The error for the trapezoidal rule, absolute value of E is no more than B minus A to the third power divided by 12n squared times the maximum of the absolute value of the second derivative on the interval AB. Similarly, the error absolute value of E using the Simpson's rule is no more than B minus A to the fifth power divided by 180 n to the fourth power times the maximum of the absolute value of the fourth derivative of the function on the interval AB. Let's take a look at an example of how to use these error formulas in approximating the integral using Simpson's rule and trapezoidal rule when n equals 4. So first we will use a trapezoidal rule formula and we will need the second derivative. So we calculate f prime of x equals derivative of 2x cubed is 6x squared. Then f double prime of x will equals 12x. Now the maximum of the absolute value of the second derivative on the interval 1, 3 is obviously when x equals 3, so in this case is 36. According to the formula, the absolute value of the error is no more than b minus a to the third power divided by 12 n squared times the maximum of the second derivative, which is 36. Evaluate this expression, we get our answer 1.5. So trapezoidal rule is not a very good approximation for this definite integral. Let's take a look at the error for Simpson's rule. So we will need f triple prime of x. Take the derivative of 12x. We get 12. So the fourth derivative of f will equal 0. And the maximum of the fourth derivative of f will equal 0. So the error, which is less than or equal to b minus a to the fifth power divided by 180 times n to the fourth power times the maximum of the fourth derivative will equal 0. So the Simpson's rule is a better approximation in calculating or approximating this definite integral when n equals 4. We'll look at another example of how to use the error formula to find n. So in this case, we want to find out the value for n such that the error in the approximation of the integral from 0 to 7, 1 over 1 plus x dx is less than or equal to 0.00001 using the trapezoidal rule. So we will recall the formula for the trapezoidal rule. Absolute value of the error is no more than b minus a to the third power divided by 12n squared times the maximum of the absolute value of the second derivative. And we want this error to be no more than 1 over 10 to the fifth power. Now in order to calculate n, we will need the maximum of f double prime. So we will need to calculate f prime first. According to the power rule, okay, it's 1 plus x quantity to the -1 power. So -1 comes down, 1 plus x to the -2. So f double prime will equals power comes down. Negative 1 times negative 2 equals 2. 1 plus x to the negative 3 power. So it's equals 2 over 1 plus x to the third power. Note that this is a decreasing function on the interval 0, 7. So the maximum of this decreasing function on this interval is when x equals 0. So when x equals 0, f double prime equals 2. Now we plug everything into the formula to calculate for n. b equals 7, a equals 0, so just 7 to the third power divided by 12, n squared, times the maximum of f double prime, which is 2, is less than or equal to 1 over 10 to the 5th power. In order to solve for n, we will need to multiply both sides by n squared. So the n cancel on the left hand side, and we will need to multiply both sides by 10 to the 5th power. So 10 to the 5th cancel on the right hand side. So then n squared will be at least 10 to the 5th power times 7 to the 3rd power times 2 divided by 12. In order to solve for n, we will need to take the square root of both sides of the equation. So square root on both sides, and you evaluate this expression. Square root of 10 to the 5th power times 7 to the 3rd power times 2 divided by 12 is approximately 2390.95. And n must be an integer. So in this case, we can choose our n to be 2391.